All right. Hello, everyone, and welcome to today's Corundum developer meeting. Today, I got a few status updates for you guys, but that's about it. Um, so I'll go ahead and get into it. Thanks for tuning in. All right. So just some status updates for today. I guess first, we got just an update on the various bugs that we've been working on. Then priority flow control, AXI virtual FIFO, which is almost done at this point. The Switch version of Corundum, additional application section interfaces for talking to the PS, the points on multi-heading. So for having both the PS and the PCIe talking to Corundum at the same time, and finally queue management consolidation. Let's go ahead and go through this stuff real quick here. All right, so the FIFO memory inference issue, I don't think there's much to say on this, and I don't see any of the MLE folks online at the moment. I think the latest on this is that it was reported to Intel, and Intel said, hey, can you try it out with the latest version of Quartus? So I think that still needs to be done. I'll follow up with those guys or try it out myself at some point and see what the story is with that. But at this point, not sure if it's been fixed or not. We need to give that some testing. All right, so priority flow control, moving on to that. We're looking at supporting PFC and Corundum, and there's several things that need to be done on this. The main thing that I'm going to be looking at in the near future is the per TC queuing infrastructure that's going to be necessary for PFC to work. So this includes basically having queues on a per TC and per port basis in Corundum. Now that we've have some of the queue management techniques from the IBM Prisma switch and whatnot, that gives kind of a framework for putting that together. Once that's done, then there's a few other kind of integration level things that are going to have to be done. We do have a student that's starting to take a look at the PFC frame handling and the pause quanta components. So hopefully we'll make some progress on that in the near future, and we'll be able to put all those pieces together. And hopefully we'll also be able to use those pieces in the switch design as well, which I'll talk about a little bit in a couple of slides. So, like I said, we need these per TC and per port queues. And with the IBM Prisma switch architecture paper talking about how to share one large memory block, that now gives a path to putting these together in an efficient way. So I'm going to be taking a look at this and hopefully in the next couple of weeks and see what I can accomplish. So we can test it out in Corundum, make sure everything works, and then utilize these FIFOs and whatnot in the switch design down the road. All right, now the main thing that I've been working on over the past couple of months now at this point is the AXI virtual FIFO component, where we can buffer a large amount of packets in DRAM. And at this point, I have it mostly done. It's working in hardware at 100 gig line rate. Tested it with iPerf graphic and whatnot, and everything looks pretty good so far. I need to finish the reset implementation, so you can reset one end or the other, and everything will cascade and it'll come out of reset correctly, because when you have like 5 different clock domains involved, every one of those also has its own reset, and coordinating all that is a little bit tricky. So I have a little bit of work to do to finish that off, but at this point that's looking pretty good. Hopefully this week that'll be done, and I'll also be able to update the Corundum designs with some code to emulate the DRAM modules, which should make things a little bit easier to deal with. Getting onto the switch design stuff, we're going to start holding a meeting that's more focused on the switch. Basically the same time, same Zoom room, same details as the current dev meeting, but alternate weeks. So this week is the current developer meeting. Next week will be the switch developer meeting. Week after that is back to the current developer meeting, so on and so forth. Anyone's welcome to join, particularly if you're interested in helping with the implementation of the switch. So join the switch channel on Zulip for more information. So I'll be posting announcements for this meeting in that channel. All right, so moving on to the Switch version of Corundum itself. I've talked about this a little bit before in terms of the overall capabilities and whatnot. We're shooting for something with a reasonable number of 100 gig ports on a Xilinx Ultra Scale Plus FPGA. Are we going to hit like 32, 64 ports? Probably not, but could you do it with say 16 ports at 100 gig? That would be, I think, a pretty nice number. I think that would be pretty achievable, but we'll see about the details. The status at this point, um, we're starting to take a look at kind of what I'm calling as functional design exploration, where I'm trying to put together a design that can be run in an HDL simulator, but isn't necessarily intended for implementation on a device. Just to get an idea of how all the pieces fit together, kind of at a functional level, and then we can start, iterating on that and optimizing stuff such that it can actually run efficiently on an FPGA. So we got the Switch channel on Zulip. This stuff is interesting. You can join that for more information and take part in the discussion, in the implementation, whatever. All right, so moving on to a few potential modifications to Corundum itself. One of the things that I've been taking a look at is potentially adding some pass-throughs to Corundum for talking to SoC type devices. So SoC devices potentially have a number of additional interfaces that could be useful to expose to the application section. Maybe you want to talk to, say, the SoC without going through the DMA subsystem. Maybe you want cache coherent access to cores, things like that. What kind of interfaces should we add, right? What exists on the various SoC devices that would be useful to have as a direct pass-through component. And one thing that I did do over the past week or two is I took a brief look at the documentation for the Zynq MPSoC for the Xilinx Versal devices and for the Intel Agilex devices, all of which have kind of a hardened processing subsystem, just to see what kind of interfaces are available and what the differences are and whatnot. And one thing I noticed is that some of the interfaces are ACE, which I think is basically AXI with a couple of additional cache coherency related signals. So to bring something like that through, you'd have to add a few extra signals. That's something to be aware of. The other thing I noticed is that the Xilinx devices tend to have a lot more ports facing the FPGA fabric logic versus the Intel devices seem to have a lot less. It's like I think the Intel Agilex has something like a grand total of 3 AXI/ACE ports. They have a lot more kind of consolidation that takes place there versus on the Xilinx devices, everything is separate. So they have like a cache coherent port. They have like on the Xilinx device, they have a cache coherent port. They have another port that that connects to the cache hierarchy at a different spot. Then they've got several ports going in both directions, basically to access DRAM and whatnot. On the Intel devices, they have like 2 ports that go from the processing system to the FPGA fabric logic, and they got 1 port that goes the other way. And you can control whether that's going to the cache infrastructure or to the DRAM by controlling some tease or sideband signals, basically. So how to reconcile all that, I'm not quite sure, but it does seem to indicate that, if you add, say, like, 3 or 4 ports to the interface, then you might not be able to take advantage of all that necessarily on, say, Intel devices. But, not sure at this point. I'm not sure if anybody has anything else to add in relation to this, but I'd be happy to add a few ports if we can kind of get this distilled down into, a reasonable set of things to add. All right, so what interfaces to add potentially is one thing. The other aspect of this is, how do you share the design between, say, 2 different processor cores? So if you have, say a host connected over PCI Express, and you have processing cores on the FPGA itself, and you want to have everything talk to the Corundum design and access the network, access the queues and whatnot. How do you make that work? So this is in particular concern for things like the 250 SoC, where you have both PCIe and the Zinc cores. I think this is probably the case for some of the Intel boards as well. Some of the Intel Agilex boards will have, the hard processing system alongside, lots of PCIe lanes. How could you make this work? So the idea that I had previously is, hey, what about basically using PCI Express, SRIOV, and handing the Zinc devices some VFs. Now, you wouldn't necessarily have some weird internal PCI Express connection. The Zinc or the processing system would still be connected via AXI, but architecturally, it would act like it was, an SRIOV VF. So the idea here is each VF has its own view over the system address space, and then we'll have to have some sort of, address space ID that's attached to, all of the internal components. So all the AXI light, register access components, as well as all of the DMA components. And this address space ID for SRIOV would map to the PFs and VFs for something that included a Zinc. Well, a couple of those address space ID code points effectively would route those operations to the Zinc components. In this case, you'd have, your master PCI Express physical function, which would be responsible for setting everything up. And that master PF that could assign queues to all of the VFs, including the Zinc, and then the Zinc VF would access would access Corundum via the AXI DMA modules, and then it would act like, just another VF. So in this case, it would have access to, all of the queues that was assigned to it by the master PF that's responsible for setting everything up. So I think this would be a pretty useful setup. I'm going to start taking a look at, all of the odds and ends that are going to be necessary to make this work. I think a large part of this is just kind of setting up this VFID or address space ID and getting that connected up everywhere. But we're also going to need, I think, in order to make everything actually usable, is some sort of potentially more comprehensive queue selection logic somewhere. It might be a while before that gets implemented, but I'm going to start taking a look at least getting some of the groundwork in terms of the address space IDs and whatnot implemented as a base that we can eventually use to put all the pieces together. So that's all I have at the moment for the multi-heading. Another thing that I've been looking at is queue management consolidation. The idea is basically to take all of the transmit and receive queues and roll them into the same queue management block. And the same thing with all the completion event queues, just roll those into the same queue management block. So we'll have one for the descriptor queues and one for the completion of the event queues. The idea is that this is going to be simpler from a hardware perspective, with fewer kind of complications in terms of sharing these blocks between different components. But there are definitely some questions in terms of performance and efficiency. Although right now the current setup is shared, so if we keep sharing things, I don't think that's going to have a detrimental performance impact. But I guess flip side is if you didn't share it, could that potentially help with the performance? Well, the flip side, the DMA engine is not shared. That's going to be responsible for reading all of the descriptors and writing all the completions, and that's also shared with the actual transfers of data. So maybe splitting things up is not really going to offer much of a benefit to performance. So definitely requires a little bit more experimentation kind of on the performance side of things, but I'm going to take a look at this relatively soon and see if I can basically take the current design and merge all of the queue handling logic. So we only have, two types of queues, kind of as a first step towards supporting variable length descriptors and whatnot, where we can just use the same logic for all the queue types instead of, either figuring out some complicated sharing solution or having a lot of duplication, which is going to use up a lot more logic resources. So that's another thing that I'm going to be looking at in the near future. I think that brings me to the end of the status update slides at this point. So if you have any questions or comments about anything, go ahead and fire away.
So not precisely.
Yeah, go ahead.
Not precisely to this last topic you just brought up, but maybe related to the work that I've been doing on bringing up the KR260 board. There were a couple of things that I wanted to bring up. The first one is, well, the pull request has been submitted. So back to you, Alex, for review. I think I tackled most of the things that you mentioned, but if not, just ping me and I'll address it. I wanted to bring up another pull request, which I sent over, which is concerning the addition of dep containers. I'm not sure if people's familiar with that, but I happen to be spending lots of my time with actually VS Code. And often the case I encounter myself with a situation wherein I'm jumping across machines and I keep installing the same things over and over again. With our customers, it's often a good practice to try to containerize the development environment, especially while you are running through simulations and so on and so forth. And I encountered that situation with Corundum's code, with Verilog Ethernet repo in particular. So that addition itself is actually a super simple Dockerized enhancement itself of the metadata. Shouldn't bother anybody using it, but for those leveraging VS Code, it might be useful to have a look at it and maybe turns as something interesting. If anyone has input or feedback on that, I'd be more than happy to take it because again, I'm adding this, I'm using it quite actively in my daily work, and so far it has turned to be interesting. So yeah, that's one of the bits. Maybe if there's anybody out there also following the progress so far within the board to the KR260, we have accomplished running the basic 10 gig example in the board, in the PL. So that's pretty much done deal. We're dealing with a few issues that we encountered with the PS, but that's kind of like running in parallel. So it shouldn't stop anyone from testing it out. The next thing that I think I'm going to try out is I'm going to see if I can leverage the RGMII files in the board. And for that, I just wanted to ask for feedback from the group. So far, I've been looking at the KC705 example, which has turned to be quite interesting. Is that a good example for doing so? And maybe that's the first question. The second question would be, once I port this to the KR260, which shouldn't be too much work, I think, my intention is to start bridging the gap and speaking to it from the PS side of things. And I know this is one of the topics Alex brought up today, but I think that what's being brought up is a bit more advanced. So I just wanted to ask for the group's input as well. Is there any recommended path for me to take while speaking from the PS?
Well, so you're mainly just looking at the UDP stack, right? Not the full Corundum setup.
So I'll be breaking the pieces and testing them separately.
Right.
For the KC7, so for the RGMII, yes, I'll mainly be looking at the UDP IP and ARP modules, as well as the AXI connectors. I think that's pretty much it. Yeah.
Right. Okay. Yeah, on the KC705, that's probably fine. I'm just thinking if there's any other design that might be better. I think the only RGMII designs I have at the moment are, 7 series, which with the Xilinx devices, you do have to be a little bit careful because there are some differences in the IO components depending on what device you're running on. But I think it's all basically the same between 7 series and ultra scale in terms of what's needed for RGMII. It's just a DDR flip flops, basically. Although I guess you might need some IO delay components as well, depending, to get things lined up. But yeah, that should be pretty straightforward, I think.
Okay, so noted down that KC 705 is the right reference design to have a look at. I'll continue in that route then and
Yeah,
try to.
I think the only RGMII ones that I have that are, 7 series or newer are the KC 705 and I think like the Nexus video. And it's, basically the same setup for both of them. So
Okay, good, noted down. And then maybe for the second part of what I wanted to ask, any suggestions on any pointers towards how to interact with the PS, let's say in a recommended mode? I know there are various ways possibly, but anything that I can leverage from past work or recommendations?
well, I mean, I know our big Zinc experts are usually the folks from MLE, but I'm not seeing any of those guys on the call at the moment. So those would be the guys to ask. You can probably ask them on Zulip though, if they're not on right now. I think they do most of their work using Peta Linux, which definitely makes a lot of sense if we're talking about running Corundum on there, because we can use the same driver and whatnot. But if you're doing embedded stuff, where you might not necessarily want to run Linux on there, but you might want to do some sort of RTOS or something, that's not something I've looked into. So I don't know what the trade-offs are of doing something like that.
So I'm pretty okay just running Peta Linux, building custom root file system with Yocto and Peta Linux, which is pretty much the same but just renamed, and I'm pretty comfortable with that. I was just wondering if folks in the community had any examples on which approach to follow. I don't think it's going to be an issue, the Peta Linux side of things. I was more on the connecting things together. So I'll just ping the Emily folks and see if they have any advice. Cool, thank you.
Yeah, sure.
Yeah.
Well, what do you guys usually do with you guys are working on what, ROS, right? Which is,
Right.
I mean, it has operating system in the name, but it sounds like it's maybe not
It's very
quite.
confusing. It's
So
very confusing.
does
Yeah,
that
the
run
robot.
on like Peta Linux on SOCs, or is that running on some RTOS, or can you do either? Or
You can do either. So
okay,
technically, the robot operating system is a meta operating system for building robot operating systems. It is actually not technically, it's not an operating system. It is a framework that runs on top. So it's a series of tools to build robotic applications. You can think of it as the SDK for robotics. It gives you a series of tools to do manipulation and navigation and perception and control, but it runs on top of an existing operating system. Whereas it is, vanilla Linux or preempt RT patched Linux or an RTOS, it's totally agnostic to that. So yeah, ROS runs on top. And so we rely on many of the interfaces of the operating system. But then while connecting things with the PL, we need to play things. Let's say it's a bit trickier, but yeah, it is a fun project. Nothing connected to operating systems. Very confusing. I agree.
okay. So you could go either way, in terms of how it's being built, depending on what the application requirements are and whatnot. I see.
Yep.
And so with Zinc devices, it seems like you're usually going to be running Peta Linux, or have you done some work with other like real-time OSs or what?
Systems. To be honest, I'm working with quite a few of them. So I do
see.
work pretty actively with Peta Linux across many hacks involving the kernel, but I'm also working with pre-built root file systems, I should say, including Debian, Ubuntu. I'm also working with QNX, with NetX, which is another real-time operating system. So quite a portfolio, yeah. But to be honest, for this, I think for this approach to leveraging RGMII, I think I'll just use the most straight approach. So either a pre-cooked root file system such as Ubuntu, or just a Peta Linux root file system right away should do. Yeah.
Okay.
Yep. Cool.
Yeah, because
Okay.
it seems like it's probably going to make quite a bit of difference what the software framework is for interacting with the with whatever's going on the FPGA side. So I don't know I mean, if you're not running Corundum on there, then I don't really know what the best approach is going to be. Obviously, with Corundum, it's going to make the most sense, at least initially, to run with Linux, because the drivers and whatnot, you should be able to just directly load those. But yeah, I think it's going to be entirely up to what you're trying to accomplish and what you're going to be doing with it, long term. If the goal
So
is to
maybe
run Pay to Linux long term, then Pay to Linux is probably the way to go. If you're planning on maybe using another RTOS, maybe it makes sense to start with that. I don't know.
So I guess from what I'm hearing from your side, Alex, maybe what makes sense for me is to, instead of diving into this new design that will use the RDMI tech in the board, maybe what makes sense is just to go with the 10 gig design that I just ported, and maybe run Corundum fully on target, and then maybe get familiar with the reference or the default way that Corundum does things. Would that make sense? Maybe.
Possibly. I mean, I think it's in large part of what your long-term goal is going to be in terms of what you need out of the design and whatnot. So Corundum obviously is more of a NIC than a networking stack like the Verilog Ethernet code is. So which one is more appropriate for your application is going to be dependent on what you're trying to accomplish. So
yeah, to be frank, I'm still learning the code, so still learning how to navigate appropriately. But I guess my goal right now is to indeed test out the networking stack. Again, individual modules and then all the way things down until the data link layer. Okay, I'll think about that and maybe try things out in Corundum, and then ping the MLE guys. I guess for now, I would need a pointer on how to appropriately, in a recommended manner, interface with the modules running on the PL, if there is any recommendation. If not, I'll just figure things out on my own. But okay, good. Thank you.
sure. Yeah, I mean, whenever you're doing anything between the Zinc kind of PS and the FPGA, it's all mainly going to be done in terms of either register operations or DMA. So that's kind of the way to get stuff at a reasonable level of performance. So Corundum is all set up to handle both of those. If you're not using Corundum, then I guess you're going to have to be just using more of the Xilinx canned IP or something along those lines. I think most of the Xilinx stuff is, you throw the XIDMA module down and use that to drive streaming data into whatever. So
Okay. Anybody else has a question? If not, I've got another one unrelated to this. No?
Going once, going twice. Nope. Okay.
Take
it away.
Performance benchmarking. So one of the objectives of this effort that I'm conducting in here is to eventually try to instrument the pieces of Verilog Ethernet and try to obtain performance benchmarking results. So far, we're discussing how we are going to conduct this. Typically, for the PS side of things, what we leverage is something called LTTNG, which stands for the Linux Tracing Toolkit Next Generation. It's a low overhead, real-time oriented tracer, which allows you to get lots of information across the layers, user space, kernel space, and so on and so forth. And it outputs essentially standardized tracing format, which is pretty useful. And it allows you to do it in a machine, but also within a number of machines within networks or subnetworks and so on and so forth. So we're probably going to trigger whatever benchmarks from the PS. That's why we want to bridge things to the PS for various purposes. Because again, our end use is in robotics, and most of the things in robotics run on top of ROS, which runs on the user space in the CPUs of whatever FPGA SoC device is. But of course, we want to make sure we're able to at least get data from the key IPs living in the PL. Is there anybody who has any recommendation on that regard? We're thinking of using the Vitis provider, which gives us a chance to collect quite a bit of information, but we'll need to hack things a bit around, because typically when you build things naturally with the Vitis tooling and it just works right away. I think in this case, we'll need to find a way to use that. But other than that, has anybody any recommendation on this regard?
Yeah, I don't see anyone
I
typing
don't
up,
have a
but
recommendation, of course, but I had one question about using Zinc devices as Zinc MPSoC, right? You are using something like that. And how is the general performance when you use Zinc devices, when you use Corundum in Zinc device? I mean, I don't have idea about how throughput of ARM Cortex A52 or something like that, and you have to do everything with them. And can you how to do things to improve the performance, and how we can use it efficiently? Actually, I just want to know about this.
I'm sorry, Adamson, but I had issues understanding you. Maybe it's my connection. It was breaking for me. Can someone maybe reproduce the question?
I think it might be my connection. I just had general. I just want to know general information about how to use MPSoC CPUs efficiently to have a maximum performance in DMA. So are you isolating some CPUs, or what are you doing? I mean,
So
I
at this
just want.
moment, if it's directed to me, at this moment, for the particular effort that we're conducting in here, so far we haven't been using the PS. We just ported straight the Verilog Ethernet into the PL, and we've run it. Right now, if you actually run it in the AMD's Cree AKR260, you'll encounter that there are some issues that's being looked with the AMD team. But fortunately, we're confident that it'll get solved soon. Now, for concerns general like performance recommendation and optimizations, I can direct you to some resources for real-time improvements, but it really depends on what you're trying to achieve in here. If you're trying to maximize or minimize latency, then there are certain things you can do. If you're trying to maximize real time, which is essentially is related to determinism, then there are some other things you might be interested on doing. It depends also very much of your underlying infrastructure in terms of operating system or real-time operating system and libraries. But generally, in our day-to-day work, we're leveraging quite a bit hypervisors. So Shen hypervisor is a good pointer. We're doing that quite actively. And that would be my kind of like low-hanging fruit recommendation. People often the case disregard this due to complexity, but it's actually tremendously useful and flexible. So that would be a
to run a hypervisor on the Zinc device.
Yeah, you can run the Shen hypervisors or the CU class. Yeah.
Not something I've looked into. Interesting. What's the advantage of doing that?
Well, there's a portfolio. I guess the lowest hanging fruit is there is I can point you maybe to that. Here it is. So there's one big issue concerning last level cache contention. And typically, here's the link that I was going to point you guys to, but this is just purely for robotics. So it may or may not be very useful to you, Adamson, but The main use case we've been using it is due to the fact that the last level cache contention in robotic applications tends to be a bit of an issue. So you have noisy neighbors generating lots of issues on that. So the hypervisors, the Shen hypervisor was actually extended to support various techniques to actually prevent this for mixed critical applications. And that's kind of like the major use case right now. But then it allows you to do plenty of things, essentially dividing your compute in the way you want to. But yeah, dealing with the LLC, the last level cache, is typically the main recommendation or the main reason why we use it. It's all about cache coloring. So that's actually what you implement and what was extended in Zen.
So then underneath Zen, are you running just one guest, or are you running several guests at the same time?
By underneath, you mean like how many guests?
Or on top of, yeah, how many operating systems are you running on there? Just one?
It depends actually it depends of the application. So often the case, what for example in automotive folks are doing right now is they have one guest typically for the infotainment, which is non-privileged, and then it's somewhat contained. Determinism is not that relevant over there, so you can pretty much run Ubuntu if you want to. Nothing against Ubuntu, by the way. But then for what concerns more critical and safety-related applications, typically you want to run an ISO 26262 certified real-time operating system. So something like QNX or VxWorks or something like that, or various instances actually. Because these days actually ECUs, which are the big computers that are into, well, big or small, but ECUs are across your cars. But right now the trend is that instead of having plenty of them in your cars, you're going to have a big one. And the new designs are actually being based on the CU plus, at least the ones that I know. So yeah, you actually leverage something like the Shen hypervisor at the low level, virtualize things, and then divide the compute from that level on, so that you actually can organize things appropriately. So yeah.
So basically, that's allowing you to kind of separate the real-time kernels from the non-real-time ones, and
Yeah.
Zen helps isolate that in multiple ways.
Yeah,
not just security, but also to get some real-time guarantees where you need them.
Yeah, I'm always very conservative when I speak about security, because any bugs at the Zen level can be escalated, and then you're blown.
Well,
but
yeah, that's true.
But yeah, but I guess.
But it's like usually when you're talking about VMs, that's kind of the idea, is that you want to make sure that you can run multiple different guests on one host, and they can't interfere with each other. But for ROS, you're interested. I mean, security is obviously important, but you're also interested in real-time stuff. And
very interested.
Apparently Zen can help with that. So okay, I didn't know that. That's
yeah,
good to know.
Very interested. Yeah, robotics is all about determinism. Robots are real-time systems. It's all about making sure the right information reaches your compute resources and then your actuators at the right time. Otherwise, your robot's gonna misbehave, which is what happens these days. So nothing new. But that's what we're working on. But yeah, definitely. Also another reason, I guess, which is not that technical, but reality is that the hypervisor approach seems to be the de facto standard in robotics and in many industries, automotive as well, for following up with safety certifications. So anything kind of like ISO 26262 or any of the related standards for safety, pretty much the first question you get is which hypervisor you're running and what's the architecture like. So yeah, that's also related. Maybe just taking a step back, any advice from anyone regarding benchmarking? Because eventually what we'd love to bring to this community is actually a benchmark that shows the performance we can get with the LNS, the Linux networking stack from the PS side of things, maybe in a ping pong test, silly back and forth interaction from ROS or from any other user space application against maybe testing out the Verilog Ethernet stack. Any advice or recommendation in that regard? Okay. Well, we'll do things.
Yeah, it's like I have not done very much benchmarking on that, really. Mostly I've been working on, benchmarking Corundum, for performance reasons. You make a change, does it help or does it hurt? Kind of important to keep track of that. So
Well, maybe on that, I can ask you, Alex. Do you do any sort of like benchmarking using simulation, like using Icarus Verilog, or do you use that for performance benchmarking purposes?
Not really. And the reason for that is I think a large part of the performance problems, shall we say, come from the Linux networking stack and PCI Express and that sort of thing. And even though we have sort of a model of PCI Express that's used for verification purposes, it doesn't really go down into all of the timing and reordering and stuff that's going to be taking place within the host CPU. So the best way to get an idea of what the performance looks like is just to run it. And you can also run a lot more traffic over an actual hardware component than you can in simulation. So because we're talking about running at 250 megahertz instead of like a few kilohertz, right? You can get a lot more data moving around. So
Sense. Yeah, that's our goal as well. We want to run on
Ye-
hardware. So
yeah, it's like even a 10-second iPerf trace or something like that at 100 gigabits per second, that would take hours and hours and hours and hours of simulation time. And you're only capturing what the simulation models that you're using captured. So
got it. Okay, so yeah, we'll try to be creative, and hopefully we can bring some interesting numbers to the group. I'm sure they'll be shocking, and Verilog Ethernet is gonna blow our minds in terms of performance. I mean, it should, compared to the LNS, it's not hard to beat it.
all right. Well, actually, one thing I will say is that you do see a lot of interesting things from simulation. So for identifying various bottlenecks on the HDL side, running through the simulation can help identify a lot of that. Once you've kind of gotten all the obvious bottlenecks figured out, and it doesn't help at all with the bottlenecks on the host side, then you got to move over and actually start testing on the hardware. But there's definitely been a few insights that I've drawn by running a simulation and just taking a close look at a few things and going, oh, well, that's not right. But yeah, aside from that kind of stuff, it seems to be that the best performance figures come from just running the thing in hardware.
Yep. Yeah, so we'll continue with that. And maybe on the simulation side of things, one piece of feedback we can give at this stage is we actually like quite a bit what's been set up in the repo in terms of leveraging Coco TV and the extensions you guys have contributed. I think you, Alex, particularly. Pretty cool, I must admit, and that has inspired some internal discussions because we plan to actually, so we will possibly contribute, maybe not to Verilog Ethernet because it would be weird, but maybe to similar repos. Higher levels, well, let me just put it this way, OSI, higher levels pushed into the PL as well, in terms of our stack. So the raw stack has, let's say, higher levels of abstraction in the OSI stack beyond essentially ARP and IP and UDP. So we do have those implemented right now and tested isolatedly, just with different tools. So we actually we are thinking of whether we should actually imitate you guys or imitate and build Coco TV extensions. I think that's how it's called, and see how we can hook it. The use of SCAPI and that was actually quite a nice design, I must admit. That was cool.
All right. Yeah, a lot of work went into that stuff just to make sure that the simulations are actually representative of the actual network. I think the initial versions of a lot of this stuff was just based on what Wikipedia said the packet formats were and whatnot.
Oh, maybe
But I
maybe on
figured
that. I saw some test benches using my HDL.
yeah, those are the old ones.
Okay, I got it now. I get it because
Don't need to
then
worry
I saw,
about those. Yeah, I haven't deleted them because I guess there's no real reason to. I guess it would save a few kilobytes maybe in the repository, but yeah, the current test benches are the Coco TV ones. So if you want to run the MyHDL ones, you can, but at some point they're probably going to stop working as stuff evolves. All right. So do we have any other questions or comments or anything? I don't know, Carlos, if you want to talk about the switch at all. I know we just met about that briefly last week, but I'm not sure if you've made any progress since then.
Yeah, from Friday I haven't made any progress, so I hope that this week
Understandable.
yeah.
Okay.
Yes, as we talked the last week, just to put some HTML code, try to try some small things to be like an initial wrapper of what can be the switch. Yeah, that's it, and I think we should check it on Monday.
Definitely, yeah. Got to give you some time to actually do some work.
Yeah,
kind of important. Well, it's good that we
Please.
finally got the papers sorted out and have some idea of what it is that we're going to build. So that's a good first step.
Yeah, I think that part of the architecture of what it could be, I think we are getting it.
All right. Well, that's going to be super interesting as that starts coming together.
Yep. We hope so.
All right. So do we have any other questions or comments? Well, I mean, if not, I guess let's see. Today's March 13th. Tomorrow is March 14th, which is National Pie Day. So happy Pie Day. Happy early Pie Day to everybody.
Same to you.
Thank you, Alex. Happy Pi Day.
Definitely got to go and celebrate, you know. All right.
Yes, last year you celebrated too. I remember you had this. T-shirt.
I think that we might have actually had a meeting on March 14th, you know. This year we're off by a day, but you know, what are you gonna do? All right.
No, there was a Pi Day. This is awesome.
Never heard about that? All right, well.
No.
You can get a pie and celebrate tomorrow, you know.
All right.
Learn something new every day.
Cool.
All right. Well, I guess that about rounds out the meeting for today then, if we got if there's nothing else people want to talk about. So we'll see you in 2 weeks. I guess everybody on the call now knows about the due time. That's good. Hopefully, I guess I should double check that the folks at MLE are aware of the new time. Anyway, sounds good. I guess, well, let me check here. 2 weeks from today will be March 27th. March 27th. All right. So we'll see you guys in 2 weeks on the 27th. And anybody interested in the switch, 1 week will be the 20th. So put that on your calendar if you're interested. All right. Sounds good.
I think one Joao, or what is his or her name, asked question about Victor. Can you look at it? Maybe.
Oh, what DPDK with CPU pinning?
Yes, isolating
benchmarking?
CPU and pinning. Yes.
Well, I'm not sure how much DPDK with CPU pinning would help with the testing the UDP stack by itself.
Yeah, it was me, sorry, who posted that, and it was to generate some traffic, in fact. Because we were talking about the performance testing, and so I thought it was relevant in this case for traffic generation, either on the same machine, on the stressing the PCI lane, or from another machine for exchange data from another machine running DPDK itself.
Right. Yeah, I think right now Corundum doesn't support DPDK, but we could certainly use it, you know, on the other end of the link. I'm not sure what tools there are for generating traffic with DPDK. I mean, I know there's like the DPDK packet gen but I'm not
No,
sure.
you have one much better one, which is called T-Rex.
T-Rex. Okay.
T-Rex, like this.
You can learn about all sorts of new interesting tools on here. That's just let's
Yeah.
see,
It's based on
T-Rex.
DPDK only, but it's much more modern than what you have regularly on DPDK. And yes, my idea was to use that as a traffic generator, but for the other side, you know, from another machine.
Oh, this is from Cisco.
It is from Cisco, yeah.
It is, yes, Alex.
Never heard of it before, but that looks pretty cool.
No.
It only runs on certain NICs, but yeah,
Yeah.
it is a traffic generator. And if you need high bandwidth, yeah, that's probably the one to do. If you're talking about latency, it's a different game, right?
Right, yeah.
Sure. So, good.
Well, you guys would know about latency too.
We also
yeah.
use T-Rex and it works quite well.
Well, what do you guys use for latency testing? Do you have
We
your own
don't
like
use
hardware
it.
solutions? Or-
We actually don't use it for latency testing. We don't use T-Rex for latency testing. We actually used for throughput testing.
Right.
We use our own pickups. We just TCP down pickups to test our latencies, or we have some simulation system now. It's like in HFT we have exchange, a market exchange. We simulate exchange and we send some packets, and it should not be at high throughput. It can be any throughput, but we should be able to measure latency. We are doing something.
So you
But
said you
we-
usually do the latency measurement in simulation.
No, not simulation, like real life simulation.
Oh, okay. I
One
see.
other server generates packet. Yes, it's something like
maybe
that.
the term for that is emulation. You have your system that emulates the system that you're talking to. Okay.
Yes.
Well, Bob, what do you guys do for like latency measurement? Do you have?
But
I'm
I heard
guessing you
a
must
lot
have custom
about
tools for that.
T-Rex.
Well, yeah, if you're just testing back-to-back cards, you can do ping pongs and measure in the host basically and do half
Right.
round.
If you have your
trips.
timestamps, yeah.
Yeah, we have that. But the other way we do it that we have is with you can at least measure it with we have a layer 1 switch. You set taps off the layer 1 switch and you have an HPT card that collects, pico 7, like 250 pico 7-second level timestamps, and then you compare, right? When things go in and out by getting a tap off those, even taking into account cables, sometimes cable lengths and so on. But so you can get an idea of the latency, or if you're
in real life, we do like this. We also do like this. In Exchange, we have cabinet and we measure from the switch. I mean, we have layer 1 switch. We also have, and we are tapping the packets.
Yeah.
And same as you said.
aggregation, yeah.
Very similar. I think everyone does the same, right?
Yeah.
Everyone has
So you don't really
similar
need any
stuff.
tools besides, some way to tap off packets perhaps, and then, high resolution timestamps.
Yep.
And then you just look at the PCAP.
Yeah, and
Okay.
compare PCAPs and analyze, yeah, that way, sure. Yeah, that's a standard way.
Pretty straightforward.
But we do run, when we test our latency in the NICs, you run kernel bypass and you go directly to PCIe and you tune everything and you run a dedicated core. that you
Yes, isolate some cores just to receive packets or something.
Right.
Yes.
And UDP, if you're going to do UDP latency, usually SOCPerf is one of the tools that we use, but there's others. And same with TCP latency, and then frame level, everyone usually has their own kind of thing where they have their own tests with frame level latency. because they have their own library usually or something like that.
Getting back to T-Rex real quick, what's the NIC requirement for that? Is it just anything that runs DPDK, or there's a more narrower selection of NICs required for that?
It's on the DPDK or on the T-Rex site. But yeah, it has to run DPDK, and then there's other ones that they say they will support officially, right? So
Okay, okay. All right, I'll take a look.
kind of like what's been tested, but you could use anything with DPDK.
Actually, no, you can't. You have to have some cards fairly recent because the low-end ones doesn't play well with T-Rex. For example,
Right.
the low-end Intel cards or the low-end NVIDIA ones, MX3, MX4, it's too old and lacks some functions that T-Rex needs. And what happened is that
Right.
T-Rex crash at startup. I use with Intel X, I think it's 720, something like this.
Okay.
It's Intel cards. I think it's 40 gigs.
Yeah,
or something like that.
You're right. There's a certain set that you need, right?
Yeah.
And have
If you
certain
take too
T-Rex.
old, it doesn't work.
I guess that's not surprising. I think I have mostly ConnectX 5. You say ConnectX 4 doesn't work, but 5, maybe.
Yeah, maybe 5 should work. I think it's really the old ones that doesn't work very well.
It should be posted on the T-Rex site, what's kind of been tested and what they know works.
Okay. I was trying to find that in the manual. I just figured I would ask because it wasn't immediately obvious. But yeah, I'll take a look at that. Oh, there we go. We have a list here. ConnectX 4. It says some ConnectX 4 supported. ConnectX 5/6 is supported. Okay. Good to know. I'll have to take a look at that. That could be a nice complement to testing stuff with iPerf.
I think on my own, I think even if it requires DPDK installation and all of that, for really interesting tests, it's much more efficient than iPerf. iPerf, you can use it like, just for testing something quickly. But if you need real campaigns, and I think I would prefer T-Rex on this. But it still requires you to install a lot of a DPDK machine and all of that. So it's challenging a little bit if you don't know how.
Well, one thing I do like about iPerf is that it tests out not just the hardware, but also like the Linux networking stack and the integration and whatnot. So obviously, you can blast a NIC with data, but to be honest, I'm not sure how useful of a test that is, right? Because if you're not connecting that data up to an application or something, it's like, what are you trying to accomplish exactly? So with iPerf, you're going through the TCP stack, and then iPerf is, responding and sending packets back and whatnot. So
yeah, but it's a test in itself. I mean, if you have really better perf with DPDK rather than with the kernel, you know that your problem is located somewhere in the kernel, depending on what you are doing.
Yeah.
So it gives you
that's true. And in terms of cutting the kernel out of the picture, so you know that your hardware is actually doing what it's supposed to do. And the bottleneck
Especially
is not there.
If you pin some CPU, at least you are supposed to have a 100% dedicated cores just for networking, not having the kernel in between. So
depends on the ultimate use case.
It's always depending on what you want to do and want to test.
Of
course, if you want to
yeah,
test
I mean, it's like right now we don't have final or relatively complete drivers for Corundum for DPDK. That's the goal, is eventually to get something like that put together. I know MLE was putting some cycles into that. I'm not sure what the current status is, but yeah, for testing something like that, T-Rex would probably be a really good solution, especially because that's DPDK on both ends. So Yeah. All right. Well, I'm definitely going to take a look at that because that definitely looks like a super useful tool.
Then the other things we use, of course, are hardware tests and like Xia or Spirent boxes that do external testing and RFC type testing. But those are
Right.
equipment you got to buy and purchase and so on.
Well, and I guess some of those things even use DPDK and things like that internally. Like, I think I was talking to some of the guys at what Ixia, now Keysight,
Ixia,
and
yeah.
some of their products are basically just DPDK software that, just standard CPU, standard NIC, and then they, generate all of the traffic that way. And it depends on what you're doing, some stuff that definitely makes sense. I think they even
Right.
have, some P4 designs that run on a switch if you want 64 ports of traffic generation, or
Yeah,
whatever.
well, we do need that sometimes when we run full managed tests. Yeah.
Yeah, so do that in P4 on a standard issue switch. That's a pretty powerful capability. So
Yeah.
All right. Well, I guess we got a few things to take a look at here. T-Rex. All right. Definitely got to take a look at that. All right. Well, let's see. Is there anything else that people want to discuss at this point? Or does that pretty much round things out for today? Going once, going twice. I think we've covered everything then. All right. Like I said, the next Switch meeting will be on the 20th, and the next Corundum developer meeting will be on the 27th. Same time as this meeting. Don't forget about the time change, and double check to make sure if you guys' times are changing that you compensate correctly for that. But yeah, I'll make sure to announce in the Zulip channel before the meeting starts. So you guys, if you're signed in, you'll know. All right. I guess we'll go ahead and adjourn for today then. Thanks to everybody for tuning in.
Thanks, everyone. Bye.
Right. Thank
See
you.
you, bye.
Bye.
Bye. Thanks.
Have a nice day. Good night for some. Have a nice day for some others. See you next.
Sounds good. Talk to you, Adam John.